Okay, so now let's consider this case. What do we do if I say let's go from negative infinity to infinity? So they're both infinity. Okay, how do you split this up? Well, believe it or not, it's not that different. What you're going to do is you're going to split this up and you're going to say, okay, I'm going to pick anything in between negative infinity and infinity. And that's not hard to do, right? Just pick something from negative infinity to infinity. So I'm going to pick c. So that's going to go from negative infinity to c of f of x dx plus the integral from c to infinity of f of x dx. And then what you do is you look at them as, and make sure they're the same, by the way. So these c values that you pick, you basically just split the integral up, which makes sense. And what you're going to do is now you're going to have two things to integrate. So you have this little guy to integrate with a negative infinity, and then you have this thing to integrate to positive infinity. Now, if this diverges, the whole thing diverges. If this diverges, the whole thing diverges. So the second anything diverges, anytime, you can stop the problem immediately and say it's a divergent integral. So you don't actually have to compute both if one of them is divergent. Now for the first guy, you do just like what I said on the last page. Okay, you're going to say let's integrate from negative infinity to c of f of x dx, and you're going to split this up and say that's the limit as a goes to infinity, sorry, negative infinity. Make sure you got the little negative. Oh man, it's really small, but you see the little negative infinity right there? From a to c of f of x dx. And make sure I'm going to put this in red so you can, hopefully it comes up on the notes. It's a negative infinity. Alright, and then the second one, you're going to integrate from c to infinity of f of x dx. That's going to be equal to the limit as b goes to infinity for the integral from b, or sorry, from c to b, f of x dx. Okay. Let's do an example to make sure that we totally understand this. So this is what you have to do. This is the definition. So if you ever see negative infinity to infinity, the first thing you do is you split it up. It's anything. See? You can even pick a number. You can pick a number like 0 or 1,000. Anything between negative infinity and infinity. Anything. And split it up that way. Okay, so let's do an example. Okay, so let's consider negative infinity to infinity for x cubed e to the negative x to the fourth dx. Now right off the bat, before I begin this, you should see that the derivative of negative x to the fourth is something with x cubed in it, so I'm going to be using u substitution. So on this test, you want to be able to recognize you're using integration by parts, you're using u substitution, etc., etc. Alright, now in this case, I'm going to pick 0 simply because 0 is an easy number to work with. I could have picked 1, could have picked 1,000. Doesn't actually affect the problem. So if I go from negative infinity, and I'm going to pick 0 as my c value, then I'm going to have x cubed e to the negative x to the fourth dx plus the integral of 0 to infinity, x cubed e to the negative x to the fourth dx. Now, like I said, there was no reason for picking the 0. It was just some finite number that I used to split up the integral. So here, so students always email me and ask me all the time, well, my friend picked 1 and I picked 355. Is that okay? Answer is yes. You're going to both get the same answer. Okay. So it doesn't matter how you split them up. Like I said, I just picked 0 because it's a nice, easy number. Okay, let's do this guy. So this is going to be called 1, my first integral, and this will be my second integral. Okay. Now for the first integral, I want to integrate negative infinity to 0 of x cubed e to the negative x to the fourth dx. Again, it doesn't matter that I picked 0. This is going to turn into, remember, now we have only a single problem, and that's this guy. So I'm going to call that a, and then take the limit as a goes to infinity. So I take the limit as a, or negative infinity, of the integral from a to 0 of x cubed e to the negative x to the fourth dx. Now hopefully you can sort of see this and do this part in your head. If you need to write out more steps, that's fine. I'm not really focusing on the u substitution because that's something we've already done. But what you'll notice is that the antiderivative of this, you're going to let u equal negative x to the fourth, and then the du is going to be x cubed dx, but with the negative fourth out front. So that's going to turn into the limit as a goes to negative infinity, and the antiderivative for this is going to be negative 1/4 e to the negative x to the fourth. So make sure that you can do that. Either you do that in your head or you use u substitution. I'm going to go from a to 0. This is going to be the limit as a goes to negative infinity for, let's see what happens. If I put in 0 into this, I'm going to have negative 1/4 e to the 0, which is just a fourth, minus minus, that turns into a plus, minus negative 1/4 e to the negative a to the fourth. Okay. Now, so let's clean this up a little bit because there's a lot of minus signs. We're going to be a little careful. So e to the 0, e to the 0 is going to be 1. That's going to be equal to 1. And that's going to turn into the limit as a goes to negative infinity. This is going to turn into just negative 1/4 plus 1/4 e to the a to the fourth. Okay, now let's, and there's a little negative out here in front. Now let's think about this for a second. We've got to be a little careful. When we put a in there, notice that the a is to an even power. So that's going to make it positive. But then we have a minus sign in front, and that's going to make it negative. So you definitely have to know what your graphs of e to the x look like. Because what happens is this is going to go to 0. Okay, so the answer is going to be equal to negative 1/4 plus 0, which is equal to negative 1/4. Now I'm going to put this over to the side just so that you can remember this, but recall that if you have e to a negative number, like e to the negative x, that's going to tend to 0. So that's how I knew that that was going to 0. Okay, so that's the first piece. Now the second piece, I'm going to not have to do all this again because I can sort of cheat a little bit if you recognize some things. Now you can integrate it from 0 to infinity, and I'm not saying not to do that. You can still do that, but if you notice some neat things about it, it's going to make the problem a lot shorter. So for example, if we have f of x is equal to x cubed e to the negative x to the fourth, then f of negative x is equal to negative x cubed e to the negative x to the fourth. Again, that makes it positive. That simplifies down nicely to just negative x cubed e to the negative x to the fourth. So the only difference between f of negative x is just the minus sign. So what we see is that f of negative x is really just equal to negative f of x, i.e. f is odd. Now the reason why this makes life a lot easier is because we don't actually have to do the integral anymore. We can just see what happens. So what that means is that, note, the integral from 0 to infinity for x cubed e to the negative x to the fourth dx is equal to, since it's odd, that's going to be the minus of the other side, negative infinity to 0 for x cubed e to the negative x to the fourth dx. And whenever you have symmetry like that, it makes life a lot easier. So that's just going to be positive 1/4. Cool. So we didn't have to integrate it again just by knowing symmetry of the function. You could have integrated it out the long way, but it would take obviously a lot more steps and a lot more time and a little bit more thought. But you get the same answer anyway. Okay, now lastly, so 3. So what that means is that the integral from negative infinity to infinity for x cubed e to the negative x to the fourth dx is going to be equal to number 1, which is negative 1/4, plus the second guy, which is also a fourth. And that's crazy, because you actually get no area if you integrate from negative infinity to infinity under the curve. Now, let's take a look as to why that's actually true. It's always good to sort of graph these things. Like I said, if I don't see it, I don't understand it. So what's happening here is, and again, I apologize, I didn't bring the right calculator with me, but if you hit y is equal to, and you have your x cubed e to the negative x to the fourth in your calculator, and I'm going to go to window, and I'm going to look at it from -3 to 3, and then I'm going to zoom fit, take a look at it and see what happens. Right. You see that because the function is odd, any area I get on this side is going to cancel out with the area on the right hand side, which is kind of neat. So you actually get the area is going to be 0. So for example, if I say calculate the area under the curve from, say, -1 to 1, look at what happens. It actually is going to cancel out. You get 0. And we recognize that from the symmetry that we did before, which is kind of cool.